Question 126, a couple of trig identities for you with the reciprocal trig functions, sec, cosec, cot. With many trig functions, there's more than one way to prove them. I'm going to just show you one way for each of these. The first thing I'm going to do with the first one is to convert the cot and the tan both into sines and coses. So cot is cos over sine and tan is sine over cos. Now when I look at what I'm trying to prove, the right hand side is just a single term, two things multiplied together, but here I've got two things added together. So it's clear that I need to combine these two separate terms into a single fraction. So to do that, I need the denominators to be the same. So I multiply the first one by cos x over cos x and the second one by sin x over sin x. So now the denominators of each of the fractions are the same. I can simply add them together. And when I add them together, I get cos x times cos x, which is cos squared x, sin x times sin x, which is sin squared x. And hopefully you can recognize that cos squared x plus sin squared x is 1. That's a famous Pythagorean trig identity. So this is 1 over sin x times cos x, and then 1 over sin x is cosec x, and 1 over cos x is sec x. So that's what we were trying to prove. So let's have a look at the second one now. Cos x over 1 minus sin x. So what I need to do here, at the moment I've got the rather interesting denominator 1 minus sin x, and I need to try to find a way of rearranging that so that the denominator is different. What I'm going to do is multiply the top and the bottom of this fraction, the numerator and the denominator, by 1 plus sin x. You might wonder, what on earth am I doing? But you can see that when I multiply the brackets out on the bottom, on the denominator, I get 1 minus sine squared x. And when I do that, of course, I can use the Pythagorean trig identity once again, because if sine squared plus cos squared equals 1, then cos squared is 1 minus sine squared. I can replace this 1 minus sine squared here with cos squared x. And when I do that, I get the rather neat thing happening, because on the numerator I've got cos x as a factor, and on the denominator I've got cos x as a factor. So I can cancel out those coses. And you can see that when I do that, I get 1 plus sin x over cos x. So I can now split that into the two fractions, 1 over cos x and sin x over cos x. And then 1 over cos x is sec x, sin x over cos x is tan x. So there's my final result and the proof complete. So there we are, that's question 126, both of the trig identities.